In this video, we are going to look for the principle of duality to solve the linear programming problem. Here the problem given is to maximize the equation and subject to the two equations. Maximize 4x1 plus 2x2 and subject to x1 plus x2 which is greater than equal to 3, x1 minus x2 greater than equal to 2 and x1 comma x2 is greater than equal to 0. To solve this linear programming problem by using principle of duality, we will follow the three steps. First step is to find the corresponding dual problem. But before directly finding the corresponding dual problem, we will represent this equation in the format of matrix multiplication. So this, I will rewrite this equation. Now here maximize, this direct equation is given, but we have to write in the format of z is equal to. So we will write maximize z equal to 4x1 plus 2x2 and subject to x1 plus x2 greater than equal to 3, x1 minus x2 greater than equal to 2, x1 comma x2 greater than equal to 0. This is our optimal, this is our maximization problem, and corresponding to equation, these are also called as a criteria. We simply assume this as the equation. These are the criteria. Now to represent this in the matrix format, we always use the format like Ax is equal to B. Now A are the coefficients of your equations, so we will represent this in the matrix multiplication format. A will be coefficient of first equation are 1, 1, coefficient of second equation 1 and minus 1. X will be x1 and x2, two unknowns, is equal to B. Now B is the right hand side of our equation, that is 3 and 2. Now this first line is for first equation, second line is for the second equation. We have represented this in the matrix multiplication format. Now this will be easy for finding the corresponding dual problem. When we find corresponding dual problem, we simply write the equation as A dash, that is A transpose V is equal to C. Now we can find A transpose by using, in transpose we just convert row into columns. Now this row will be get converted into column, 1 1 will be 1 1 and this row will be get converted into column 1 minus 1. This is the transpose of my A. What is V? V is not given, so V, as there are two unknowns x1 and x2, we will assume V as V1 and V2, or simply we can say how many unknowns are there in our Z equation, that many V's we will have. So here we have two unknowns, we will write V1, V2, and C is the coefficient of variables in your equation Z. So here we will not write this 3 2, instead of that we will write 4 and 2, the coefficient of x1 and x2 in our Z maximization problem, 4 and 2. This corresponds to, these two values correspond to the Z equation, and this is the transpose of your matrix. Now we have written this in the dual problem format. Same way we have to convert our this equations into dual problem. So we exactly do the opposite of each and everything. Here the problem given is to maximize, so we will write minimize Z. We are finding the dual problem, so exactly opposite of maximum is minimum. Minimize Z, and instead of this x1 and x2 we will write v1 and v2. So this equation will be here. Now the trick is on the right hand side of your equation Z. We already use 4x1 and 2x2. Now what we will do, we will use the matrix that is matrix of B, that is 3 and 2, right hand side of your criteria equations 3 and 2 as the coefficient of your new variables in the equation Z. So it will be 3v1 plus 3v2. Why we have used v1, v2? Because we are now finding the dual problem, corresponding dual problem. So we will replace all the x1 with v1. Now equation will not be get changed. So this will be v1 plus v2. Instead of greater than equal to, what we will write, we'll simply replace it with the opposite of that greater than equal to, that is less than equal to. And here instead of 3 we will write first coefficient of our equation, that is 4. Or we can say that instead of using this thing we have to write this, we will use this formula for our new equations. Now for the second equation, our equation will be v1 minus v2 is, now we will keep this as blank, is 2. But what is this 2? Now here for the second criteria, the symbol was greater than equal to, we will simply replace it with less than and equal to, and v1 v2 is greater than equal to 0. Now we have find the corresponding dual problem. Now we will go to the next step. Second step is to prepare the simplex table, or write standard mathematical LPP. Write all this equation in the form of standard mathematical linear programming problem, or prepare the simplex table. Now the rule for this preparing the simplex table, we always follow the rules that if for criteria, now this is the formula for adding or preparing the standard mathematical form. We are just adding the slack variables in our equation, and now instead of referring this equation, we will refer these new equations. We will prepare the new format for this equation for solving the further tables. Now first, this equation will be called as a constraint. This is constraint 1 and this is a constraint 2. We will refer this. Now rule is, while you add slack variable or artificial variable, you have to look at the symbols of this constraint or equations. Now the symbol is less than equal to. If the symbol is less than equal to, we will add slack variable, or if the symbol was greater than equal to or equal to, we will subtract the slack variable and add artificial variable. But in these two equations, the symbol is only the less than equal to, so we will write that equation as these two. We will keep the first line for the z equation, and we will write the constraint equation v1, and we are just writing left hand side of our equation v1 plus v2. Now here symbol is less than equal to, so for first equation we will add slack variable 1 plus s1, and instead of less than equal to, we will simply write, as we have completed with our left hand side, we will simply write equal to symbol and write the right hand side as it is. Now for the second constraint or equation, the left hand side is v1 minus v2. We have to add slack variable or artificial variable. Symbol is less than equal to, so we will follow this thing, that is we will add slack variable. S1 is already used. For second equation we will add another variable, that is we will add S2. Now we have completed with the left hand side, so we will write equal to right hand side, that is 2. Now our two constraints or simply equations are completed in the new format of LPP, new standard mathematical form. Now we will move to writing our z equation. We will write, that is minimization of z is equal to. Now while you write right hand side, just keep whatever you already have in the right hand side as it is, that is 3v1 plus I think it's 2v2. I may had, it's 2v2. It's 2v2. Now we have to wait. Here what we will write, we will see the formula. Whether we have added any S1, S2, yes. If we have added, we just have to write in the format of addition of 0 into that slack variables. So plus 0 into S1 plus 0 into S2. Whether we have added any artificial variable in our equation? No. If we have not added, so we will not going to use this formula. If we have added, so we will use this formula, but we have not added any slack variable because in our equation there was no symbol of greater than equal to, so we will simply write this. Now our new format of this equation is completed, so we will relabel these equations. That is, suppose Roman 1, this is equation 2 and this is equation 3. These are simply the constraint and this is our optimal equation. This we have to find. Now we will prepare the simplex table for this. I will write. This will be the simplex table for our equation. Now we write Cj as a column and Cb as the rows. Now and the basis. Now in the basis what we will have, all the unknown variables which are written in our equation of z. So this will be our final new equation. That is, we have v1, we have unknown variable v2, we have s1 and s2. Apart from this, we will always going to find the solution and the ratio. And along with this, what we write in the Cj part, these are the basis, and in Cj part the coefficients of all these variables in our equation of z, that will be written. So v1, coefficient of v1 is 3, coefficient of v2 in equation of z, that is 2, coefficient of s1 is 0, coefficient of s2 is 0. Okay. Now when we write the rows, we always look for the constraint, another equation other than z. So in the first equation, whether we have added any artificial variable? No. If we have not added any artificial variable, we will look for the slack variable. Whether we have added any slack variable? Yes. So we will just simply write the name of that slack variable, that is S1. And the coefficient of S1 in the z equation is 0, so we will write that as 0. This black color I have made, that is the part of your coefficients in the equation of z. Now we will look for the second equation. Here we have not added any artificial variable, but we have added the slack variable. Okay, so we will just write the name of slack variable. We will not look for what is the sign of that slack variable, that is S2. And what is the coefficient of S2 in equation of z? That is 0. So we will write that 0. Now I completed with this column, filling the column labels and row labels. We have to write this solution, and now we can write this part, only this part, solution. Now solution will be your values of right hand side of your equation constraint. Here in this we have value as 4, and for the equation 2 we have right hand side as 2, so this solution will be 2. Now all these entries will be for the first table. This will be the coefficient of all the variables in your equations of constraint. So we will write that the coefficient of v1 in the first equation is 1, of v2 is 1, of s1 is 1, of s2 was not here, so it will be 0. Now for the second equation, coefficient of v1 is 1, coefficient of v2 is minus 1, coefficient of s1 is not there, coefficient will be 0, coefficient of s2 is 1. So we have completed with this our filling the column and row entries. Now what we have to do for continuing this method, we will have to find the zj first. Zj is equal to summation of the cb into corresponding aij. This is the formula. Now how we will find this? we have to find this entry. So this entry will be founded based on how many rows we have, that many summation we will do. So that formula is, all these entries are called as Aij. Now we will go for finding this value. So this will be 0 CB value corresponding into Aij. So this is 0 into 1 plus 0 into 1 is equal to 0. Now in the same way it will be 0 into 1, 0 into minus 1, this will be 0. Now we will not going to calculate this thing in mathematical calculation, because 0, these two entries CB values of two rows is 0. So 0 into anything is 0. So this will become simply 0. This will become simply 0. Now we have calculated the CB values, Zj values of this, that is 0, 0. We have to calculate the next value, that is Cj minus Zj. This is important value because it will lead to us with another iteration. This is our first iteration. Now this value is, this is the Zj value. Now this value will be, for this column will be Cj value is 3 and minus Zj value we have founded, that is 0. So it will be 3. For this column Cj value is 2 and Zj value is 0. So it will be 2. For this column Cj value we have found, Cj value is 0 minus Zj value is 0. So it will be 0. For this column Cj value is 0 minus Zj value is 0. So it will be 0. So we will enlist all this in the proper way, that is Cj minus Zj is 3, 2, 0, 0. Now for proceeding for the next iteration, we have to look for what are the values we have in the Cj minus Zj, and whether our problem is maximization or minimization. Our problem is minimizations, mean exactly opposite values we have to check for. If for the minimization problem, if all entries of Cj minus Zj, all Cj minus Zj entries are 0 or greater than 0, then we will stop with this iteration. We will not go for finding the next iteration, and whatever we are getting, that will be our solution. And the Zj value for this is also 0. Now the Zj value we have left with this column, that is Zj value is 0. 0 into 4 plus 0 into 2, that is 0. Now here this comes, we come with our final solution, that is Zj value minimum Zj or Z value is 0, and to conclude with our solution, we will always going to find what are the solution value. This is our solution value. So we will write minimum value of Z is 0 at V1. This value is of V1 and this is value of V2. At V1 equal to 4 and at V2 is equal to 2.